No, sir.
Okay. So basically in the previous class we had studied about the dehydration, right?
Yes, sir.
So today we are going to start the mechanism of this dehydration, and also there will be a test. So about the mechanism, I'm going to start mechanism. So see, this mechanism have three steps, and we will learn step by step. So in a step one, what happens here? I'm going to write it and then explain it. Formation of protonated alcohol. Formation of protonated alcohol. What does this mean? We are going to react alcohol with proton. So if we have ethanol, as you can see the structure of ethanol, CH3, C2, CH2OH, that means it will be like this, H and OH. And as you know that this oxygen will have two lone pair. And when you are going to react this with proton, that is H plus, you can see this H plus is electrophile. So it will attack here and there will be a formation of product, and this step is basically fast. So you can see the product will be basically CH H H, and then there will be two hydrogen that will be like this, H and H, and there will be O and then H. Since oxygen donated one of its electrons, so it will have positive charge, and it will be like this, and it will have one lone pair because it had two lone pairs. Now you can see the step two. The step two is basically slow, and here formation of carbocation took place. Formation of carbocation, and it is the slowest step. That means rate determining step. It is the slowest step, and hence rate determining step. Rate determining step. So we will use this as reactant, and there will be formation of carbocation. Aman, are you there?
Yes, sir.
So Aman, do you know positive charge on oxygen is more stable or less stable? Positive charge on oxygen. I have explained this in previous organic chapter. So can you tell me this reactant is more stable or less stable?
Sir, more stable.
No, no. Can you tell me whether oxygen is more electronegative or less electronegative?
Sir, it's less electronegative.
How can you say that? Oxygen is the second most electronegative element.
Okay, sir.
So electronegative element is has negative charge more stable than positive charge. So in order to get a stable, this oxygen will take electron from oxygen to make itself neutral. And now you can see this will have CH3, CH2 plus. I just wrote it in condensed form, and H2O will be eliminated. Are you getting my point?
Okay, sir.
Now step 3, formation of ethene by removal of proton. Formation of ethene by elimination of proton. So this we will take this as a reactant. You can see this hydrogen CH3 it was, and this will be basically CH, and and there will be H, and there is positive charge. Now this will be also, you can see, fast reaction. What happens? Carbon will take electron from hydrogen, and hydrogen H plus, that means proton will be eliminated, and there will be formation of double bond between carbon carbon. So this is the mechanism of dehydration. Should I slide it up? Anyone have any doubt?
No, sir.
No, sir.
Very good. Please let me know when you are done with this. Let me know when you are done with this. Are you done with this?
Almost, sir.
Okay.
No, sir.
Okay, take your time.
Yes, sir.
Very good. What about you, Aman?
Yes, sir. Done.
Okay. So this is the mechanism of dehydration. Now I'm going to give you a question on this. Then we will move to the next chemical properties. So the question is simple. Here it is. OH. And you are going to react this with H2SO4 and heat. Please let me know the name of major product. How many products are there and name of the major product? I think you can do it. How many products are there and also the major product? Are you done with this? How many products are there?
So I'm not sure how many.
Okay, see, what you need to do is it's very simple. So this is the structure, right? And here you have OH, and you can remove hydrogen from here first. And there is also like this. Okay, I'm going to show you it in a very easy way. Wait, now this is the structure. As you know that OH is here. Now you can remove hydrogen from here. Now this is the structure. Now you can also remove hydrogen from here. So when you are going to remove hydrogen from here and OH from here, what will be the product? The product will be double bond will be here, yes or no?
Yes, sir.
Yes.
Now if you are going to remove this hydrogen and OH, it will be, the product will be basically like this, double bond will be here. And if you are going to remove hydrogen from here and OH from here, the product will be like this, yes or no?
Yes, sir.
Yes, sir.
Which one will be the major product? So see, this may looks complicated, but you can write it also like this. It may look complicated, but you can also write this as this and this as this. Yes or no? Can we write this? Both are
Yes,
same.
sir. Yes.
Yes, sir.
So it's very easy, basically. So you can see how easy it is. Can you name the product? Please write it and let me know the name. Let me know when you are finished with this.
Sir, 1,3 dimethylpentene.
Which one are you going to name it?
I said I'm talking about the second, middle one.
1, 2, 3, 4, 5. So we are going to give preference to double bond, and a double bond from this side got second position. So it will be good. Now 3,4. There is 2 methyl group. So 3,4 dimethyl, and 5 carbons are there. So pent, and double bond at position 2, pent 2. Rim, did you get the same answer?
Yes, sir.
Let me know when you're done with this.
Yes, sir. Done.
Okay. What is the name of this? Can you name it?
Sir, 1,3 dimethylpentene.
From where you give number?
Sir, from the right side.
Right side. 1, 2. So on second position you are getting methyl, na?
Okay, yes, sir. And the other one at 3. So 2,3.
So it will be 2,3, na? It will be 2,3 methyl. Are you getting my points?
Yes, sir.
2, 3 methyl, then come to the parent chain. How many carbon are there? Pent. And where is the position of double bond? 2 in. Can you name this? Rim? Are you? Do you have any confusion or problem in nomenclature? Are you done with the third? Rim? Do you have any doubt in this?
No, sir.
So please tell me the IUPAC name of this compound. Ayman, can you do this or not?
Yes, sir, I can.
You are taking too much time for this small nomenclature. You are
No,
going
sir,
to give
I
preference to
couldn't
double bonds,
hear
so we
you.
have just started from here 1, 2, 3, 4. So its name will be 2-ethyl. You can see it will be 2-ethyl and then 3-methyl, 2-ethyl and 3-methyl, and then pent 2-ene. Sorry, pentene, pent 1-ene, or we can write pentene. Please write it. Let me know when you are done with this. Are you done with this? Ayman and Reem?
I'm still writing, sir.
Okay, please write it and let me know.
Done so.
Very good. Ayman,
Yes, sir. Done.
now the next chemical properties is basically oxidation. The previous one was dehydration. And now we are going to oxidize alcohol and we will see what it gives. So how we are going to oxidize it? It's very simple. Simple. Please write with me. Oxidation of alcohols involves the formation of a carbon oxygen double bond. Carbon oxygen double bond with cleavage of an OH and CH bond. It's very simple. Whenever alcohol oxidized, there will be carbonyl group form. That means carbon oxygen double bond will form. And how it is gonna oxidize? When cleavage of OH and CH bond will break. As you know that oxidation means loss of hydrogen. Yes or no? Loss of hydrogen or gain of oxygen. Gain of oxygen or loss of hydrogen. So if you have alcohol like this, you can see, and you know that this bond will break, and also there must be a hydrogen that will be associated with this carbon. That bond will also be broken. This two hydrogen will be eliminated, and you can see there will be formation of a double bond between this carbon and oxygen. So this is how alcohol oxidize, bond breaking, this bond and this bond. Please do write it. Let me know when you are done with this.
Done so.
Write a point also. This reaction is also known as dehydrogenation. This reaction is also known as dehydrogenation. Dehydrogenation, that means removal of hydrogen. Are you getting my point?
Yes, sir.
Okay.
Yes, sir.
Please write it. Please write it. Are you done with this, Rim and Ayman?
Done, sir. Yeah.
Yes, sir.
Okay, okay. Ayman, see, and Rim. Primary alcohol oxidizes. First, it oxidizes to an aldehyde, and if you are going to again oxidize it, which in turns is oxidized, if you are going to again oxidize it, then carboxylic acid will oxidize to a carboxylic acid. It's very simple. You can say if you have RCH2OH, that is alcohol, and if you are going to oxidize it, see what happens here. Whatever I explained, you know that RCH and there will be OH, and you know that there will be H. There must be hydrogen with this carbon and oxy. There will be hydrogen with O. So then it will be converted into RCHO, aldehyde. Again, if you are going to oxidize it, you know that this will be double bond O and H. This is aldehyde. Again, if you are going to oxidize it, it will be converted into C double bond O, OH, carboxylic acid. So always remember, whenever alcohol oxidize, it will be converted into aldehyde and then carboxylic acid. But if you are going to use a very strong oxidizing agent, so alcohol can be directly converted into carboxylic acid. Alcohol can be directly converted into carboxylic acid. Are you getting my point?
Yes.
Yes, sir.
Okay. So I'm going to write this. A strong oxidizing agent strong oxidizing agents like acidified potassium permanganate are used for getting carboxylic acid directly. Please let me know when you are done with this reaction so that I will be writing a reaction for this statement also. Are you done with this?
No, sir. I'm still writing.
Yes, sir. I'm done.
Very good. Please let me know when you are done with this room.
Done, sir.
Very good. So if we are going to write a reaction for this statement, it's very easy. If you have RCH2OH and if you are going to write H plus, that means acidified KMnO4 potassium permanganate, then this will be directly converted into carboxylic acid. Are you getting my point? If you have CH3CH2OH and you are using potassium permanganate, please write the name of the product.
Done, sir.
Then what is the name of the product? This will be directly converted into carboxylic acid, that will be equal to CH3COOH, right? Is that clear, Rim?
Yes, sir.
Aman?
No, sir. Just 1 minute.
Okay. If you are going to use mild oxidizing agent like CrO3, chromium trioxide, if mild oxidizing agent like CrO3, then primary alcohol will be converted in aldehydes, directly aldehydes, not carboxylic acid. If you are going to use 2 times this anhydrous, this should be used in anhydrous medium, dry anhydrous medium. The medium should be anhydrous. So if you have RCH2OH and you are using CrO3, it will be converted into only aldehyde. And if you are again going to use this CrO3, then it will be converted into carboxylic acid. Please do write it. So how we are going to oxidize it? We will be in need of oxidizing agent. Please let me know when you are done with this.
Done, sir.
We just need to remember the reagent like this acidified
Yes, sir.
KMnO4 and this CrO3. There will be another reagent that will be known as PCC. So basically, we can write a better reagent to oxidize primary alcohols to aldehydes in good yield is pyridinium. It is also a reagent. Pyridinium, chromate. That means basically PCC. So if you are going to use PCC, if you have any type of alcohol, I'm taking example from NCERT, what will be its function? It's very simple. It will just do the same oxidation of this alcohol. So as you know how we are going to oxidize it, CH, I'm going to explain this part. This will be, so what happens here? It's very simple. This will be broken. This will also be broken. And the rest part will be same. So it will be CH3, CH, double bond, CH, and then CH. And then it will be C double bond O. Wait a minute. 1, 2, 3. There will be CH2. Okay. So there will be CH2 and then this. So you can see this alcohol is oxidizes into aldehydes easily. Please write it. So primary alcohols oxidizes into aldehyde and then carboxylic acid. But when we are talking about secondary alcohols converted into ketones. Basically, secondary alcohols oxidizes into ketone.
Yes, sir, I'm done.
Done, sir.
Very good. Now we are going to talk about secondary alcohols. Secondary alcohols are oxidized to ketones. They are oxidized to ketones by chromic anhydride. CrO3. So what will be the oxidation? This H will be removed, this H will be removed. So there will be formation of ketone. Always remember that tertiary alcohol cannot be oxidized, You know why? Because tertiary alcohol does not have, you can see, tertiary alcohol. Focus here. So there is hydrogen with H, but this carbon does not have hydrogen. That's why tertiary alcohol does not oxidize. Okay. If you want to oxidize it, there will be elimination. Elimination takes place, and alkene will form. Please do write it. Are you done with this?
No, sir, almost.
Okay, take your time.
Done, sir.
Aman, are you done with this? Are you done with this? Aman? Rim,
Yes, sir.
are you done with this, right?
Yes, sir.
Okay. Aman, what about you?
Yes, sir.
Okay. Now I'm going to take your test for this week. I'm gonna write the question. Please write with me. So question number 1 is here. So how will you synthesis pentane one all using suitable alkyl halide? Question number 2. Give equation for the given reaction. Please write the question with me. Oxidation of propane one all with alkaline MnO4 solution. Next question. How are the following conversions carried out? Please let me know if you are done with the question number 1. methyl magnesium, bromide 2-methyl propane, 2-methyl propane, 4. Please let me know when you are done with this.
Yes, sir. Done.
Are you done with this, Simon?
Yes, sir.
Okay. Can I change the slide? Rim?
Yes.
Okay. The last question. Question number 4. So, how would you? Please write with me. Synthesize the following alcohols from appropriate alkenes. The first one is basically like this. Please do this question and make a PDF of this. Make a PDF of your solution and send it to coaching's WhatsApp number. Okay. I'll
Okay,
be
sir.
here waiting for you. You have time. You have only 25 minutes.